Let's understand what the zeroth root of x really means, and why it doesn't actually exist, even though it sounds like it should. The nth root of x means a number, let's call it y, that when multiplied by itself n times gives x. For example, the square root of 9 is 3, because 3 times 3 equals 9. The cube root of 8 is 2, because 2 times 2 times 2 equals 8. We can also write roots using powers with fractions. X to the power of 1 over 2 means the square root of x, and x to the power of 1 over 3 means the cube root of x. In general, x to the power of 1 over n is the same as the nth root of x. Now, what if n equals 0? Then we'd be talking about x to the power of 1 over 0, the zeroth root of x. But 1 divided by 0 doesn't make sense. We can't divide by 0, so something strange happens. Think about powers for a second. 2 to the power of 0 equals 1. 3 to the power of 0 also equals 1. In fact, any number to the power of 0 equals 1. So if we ask, 0th root of 1 gives 2, or 3, or any number at all, that means there's no single answer. The 0th root just doesn't exist. But here's where it gets interesting. If we look at x to the power of 1 over n and make that denominator smaller, like 1 over 0.001, that fraction gets closer and closer to infinity. In math, we say as n approaches 0, x to the power of 1 over n gets larger and larger. It heads toward infinity. That's why people say 1 divided by 0 is infinity, even though it's not actually defined. So the 0th root of x doesn't exist because it would mean dividing by 0. But as we get close to it, the value grows without limit, moving toward infinity.